Okay there, Math 1. In this particular video, we are looking at understanding correlation coefficients. So what in the world does that mean? So we have a little bit of a textbook definition here. So estimating the correlation coefficient of a linear fit. So of course, our linear fit is that line of best fit that's going through our scatter plot and trying to meet and match our data as best as possible. So one way to quantify the correlation of data is called or is with the correlation coefficient, and is denoted, which just is going to have R is equal to. Okay, the correlation coefficient varies from -1 to a +1 with the sign of R corresponding to that type of correlation. So if it's a positive correlation in your scatter plot, or has a positive slope, of course, R is going to have be a +1 or close to +1. If it's a negative correlation that has a negative slope, of course, it's going to have a negative value with R. So the key part here to look at is the strongly correlated data points look more like points that lie in a straight line and have the values of R being closer to 1 or -1. A weakly correlated data set would have values closer to 0. Okay, so there is a precise particular mathematical formula where you can calculate R for the purpose of Math 1, and currently where you are at in your math educational career, we're just going to be using Desmos to calculate our correlation coefficient because it's beyond the scope of this particular course in Math 1. But of course, if you want to dive further into statistics, there you will get into the formula and how it is actually calculated. So as you can see, this particular graph right here, number 1, this one right here, okay, it is starting up and going down, so it has a negative slope, and my line and my data points are very, very close together. So we are going to say that R is close to -1. Why is it negative? Because my slope was negative. Why is it close to 1? Because the line was very, very close to those data points. Versus this one, it's going to be weak because my data points are further away from that line of best fit. Now it's still going to be negative. R is still going to be represented by a negative number, but it's not going to be close to up -1. It's going to be closer to 0. Okay, here's a strong positive correlation. So as you can see, it's positive because it's starting down and it's going up. So positive slope, positive correlation, and it's going to be closest to +1 because my scatter plot dots or my information here is as close to the line of best fit as it's going to get, versus this one is further away. They're more scattered from that line of best fit. So the R is still going to be a positive number, but it's going to be between 0 and 1 and probably closer down to that 0 side. Okay, so let's take a look at some of these and really apply them. Okay, so what do you think that this particular correlation coefficient is going to be for this particular graph? Well, these points are scattered literally everywhere. So this one has no correlation, and so that R value is going to be as close to 0 as it's going to get. Okay, so if I was to draw in a line of best fit, my points here are still kind of scattered all over the place. Now it is positive, so R is going to be a positive number, but we're going to get it as, it's not going to be close to 1 because those points and those data plots are still scattered even if I drew a line through there. So it's going to be between 0 and 1 and probably really closer there to that 0 sign. Okay, now the next one is a negative because it's starting up and it's going, well, if I drew a straight line, we would say that those data points are pretty similar or pretty close to a linear line. And so R is going to be negative, but it's going to be as close as it can get to -1. Okay, that's kind of what that arrow is. I don't know. It doesn't have to be there. I'm just putting an arrow there to let you know it's going to be as close to -1 as possible. So now let's really dive into some tables where we're going to figure this information out. Okay, so we have hours of study, exam scores. I'm going to pop into Desmos and put this table in. Okay, y'all, so I'm going to go ahead and put in my information here into Desmos, and I am now going to calculate my line of best fit so I can see the line in there. So we're going into y sub 1, mx sub 1. Don't forget the plus b. Okay, now there are some key features here to look at. And so as you can see right here is, of course, your slope and your y-intercept, but it's also giving some stats information. And yes, it's giving r-squared, and we're going to get to that later, but my r right here is going to be my correlation coefficient, and that is 0.8823. Okay, so I'm going to head in to this one, and I'm going to write that down. How do I get the mouse not to be focused? Okay, there we go. And it was point. I forgot, was it 0.08? No, it was just 0.8. There was no 0 in there. Y'all was about to have us all the way messed up. Okay, so if we just take a look at 0.8 only, now that is pretty darn close to 1, because it's like 0.80. Pretty close to 1. So this one is going to be one of those positive, because there was no negative sign. My slope in my scatter plot, it was positive. It was going up. Okay, and it is going to be a positive, but it's also going to be strong, because 0.8 is pretty close to 1. It's closer to 1 than it is 0. Okay, let's go ahead and take a look here at the other one. And I'm going to head into Desmos and place it in there. So just give me one moment and I'll be back. Okay, I went ahead and put my table into Desmos. I went ahead and even did the line there for you. And I'm seeing that I have my correlation coefficient. If you also don't forget to press that zoom sign, and it will graph it there for you. And my correlation coefficient is 0.9377, and that is also pretty close to 1. So this one is going to be another positive, but a strong. So positive and a strong correlation. Okay, let's try another one.